Stars form from vast clouds of gas and dust in space, known as nebulae. These clouds are primarily composed of hydrogen, which is the fuel for nuclear fusion. The process of star formation can be broken down into several key stages. A disturbance, such as a nearby supernova explosion, triggers the collapse of a portion of the nebula. As the gas and dust particles move closer together, gravity pulls them inwards, causing the material to heat up. As the gas continues to collapse, it forms a dense, hot core known as a protostar. During this phase, the core is not yet undergoing nuclear fusion, but it is heated by gravitational contraction. When the temperature and pressure in the core of the protostar become high enough, around 10 million K, nuclear fusion begins. This marks the birth of a true star. In this process, hydrogen atoms fuse into helium, releasing energy in the form of light and heat. The star stabilizes as it enters the main sequence phase. Stars spend most of their lives in the main sequence phase, where they fuse hydrogen into helium. However, as the star ages, it exhausts its hydrogen supply and undergoes significant changes. The evolution of a star depends on its mass. Once the hydrogen in the core is depleted, the core contracts and heats up, while the outer layers expand and cool, turning the star into a red giant. The star starts to fuse helium into heavier elements like carbon and oxygen. In the final stages, the outer layers of the star are shed, creating a planetary nebula. The remaining core becomes a white dwarf, a dense, Earth-sized remnant that gradually cools over billions of years. High-mass stars expand into supergiants and begin fusing heavier elements such as carbon, oxygen, and eventually iron in their cores. When the core reaches iron, fusion stops, and the star can no longer support its own gravity. The star undergoes a violent explosion known as a supernova, which disperses elements into space and can trigger the formation of new stars. Depending on the mass of the remaining core, it may collapse into a neutron star or, if the core is sufficiently massive, collapse into a black hole. Stars play a critical role in the life cycle of elements. Through processes like supernovae and stellar winds, they scatter heavy elements into space, enriching the interstellar medium. These elements can later become part of new nebulae, and eventually form new stars, planets, and even life. The study of stellar evolution helps astronomers understand the life cycle of stars and the broader processes that shape the universe.